Alright, so first, step 0 says we got to factor. So this becomes x plus 5 and x minus 1. All over I can factor out of 4, and that leaves me with x minus 1. Those x minus 1s cancel each other out, so that leaves me with f of x equals x plus 5 over 4. Yes? No. Okay. So that tells me that my domain is all real numbers, which tells me that there is none vertical asymptotes. The degree on the top is uno. The degree on the bottom is zero. So the top is greater than the bottom, which tells me that there is none has. Yes?
So then you just direct it as well.
Channel my inner Dave Hester. Yep. F of their whole is their whole plus 5 divided by the 4 gets me 5/4, which tells me that I have an, oh wait, tap the brakes. Let's make that look nice and pretty. Which tells me that I have a y-intercept of their whole, comma, 5/4. Zip it. Zip it. Which is right there. YB? That's yeah, buddy, man. Yeah. Then we go x plus 5 equals 0. So that tells me that x then equals -5. So that tells me that I have an x-intercept at -5, comma 0. Oklahoma, where the wind comes across the plain. And right there.
Are you okay?
Are you okay?
I'm okay. Are you okay?
I'm talking normal up here. What are you doing? You hearing crazy things? Do I have a hole?
Yes.
Yes, because I factored something out. I factored out x minus 1. So x minus 1 equals 0, so x equals 1. So I need to find f of 1. 1 plus 5 is 6. Divided by 4 is 6. Divided by 4, which we'll just call 3/2. I like reduced fractions. So that tells me that we have a whole at 1, comma 3/2. So I go on to my graph and I put a hole. Yeah? Now, let me ask you a question. What kind of a function am I graphing? Line, right? Really, I mean, what we're really dealing with here is 1/4 x plus 5/4. So that gives me, if I would just graph that line, that gives me a y-intercept of 5/4. And then I go from that point, I go up 1 and right 4, up 1 and right 4, up 1 and right 4, right? Yep. Or left 1, or excuse me, down 1 and left 1, down 1 and left 1. With me? Okay. So my extra points, 1, 2, 3, and 4 are right there. 1, 2, 3, and 4 are right there. 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. So somebody in the peanut gallery said I just graph it like a normal line. And the answer, I wanted to say yes,
Well, you put a hole in it.
but we put a hole in it. Okay? So, no. But yes. But no. But yes. We're recording this, Hunter, just so you know. So I'm not just talking to the chalk tray. Okay, there's a microphone right here. We'll wake the people up right now. Son of a, come on. Here, going on right now. Okay,
I'm gonna listen to this screencast.
this one.
Yeah.
You only gotta listen for the first 6 minutes.
Oh, good.
Yeah, that's where we're at right now. Now it gets crazy. All right, here we go. All right, so when determining the horizontal asymptotes, I want to focus in here on step number 2 of our 8 steps. Excuse me. Okay. So when focusing on step number 2, that's finding the horizontal asymptotes. We're comparing degrees, correct? Right? And so one of my options is top is less than bottom, right?
Yep.
And what happens in that case?
No horizontal line.
No. Top is less than bottom.
Y equals 0.
Y equals 0 is my horizontal asymptote. What if they're the same?
It's Y equals A over B.
The lead coefficients, right?
Yeah.
What is the other case?
If the top is greater than bottom. No horizontal line.
There's a none case, right? It's this last one that I want to chat about. And it's this last one when the top is bigger, where we've got to do one more check. Okay? And that one more check is if the degree of the numerator is 1 bigger than the degree of the denominator, and we've already gotten rid of our common factors, we get what's called a slant asymptote. What's that? Okay. It's an asymptote that's not vertical and it's not horizontal. It's on a slant. So it's just a line. It's just a regular old line. But it's an asymptote. So what?
You have to give us more words.
It's really not that much more.
It just.
Okay. So, now, that leads us with step number 6, the last step. Okay? Step number 6 is we need to find that slant asymptote. But that slant asymptote is only going to happen in this top is greater than the bottom by 1 case. If it's by 2, it's a parabolic asymptote or a quadratic asymptote. If it's by 3, it's a cubic asymptote. Okay? If it's by 4, it's a quartic asymptote, and so on and so forth. We're not going to get that far. We're going to stop at slant asymptotes. Okay? So, here's how you go about finding it. There's 3 sub-steps to finding the slant asymptote. The first sub-step is, now remember, we're dealing with a function that has a function for the numerator and a function for the denominator, right? Well, what are we really doing when we have a fraction? What mathematics is associated with fractions? We're dividing. So what I want you to do first is I want you to do this division. I want you to divide P of x by Q of x. How are you going to be able to do that division?
Are we dividing the degree?
No, dividing the whole polynomial. So how do we divide polynomials? Think chapter 5. What? Synthetic division is one way, right? Hold on, tap the brakes, child. Let's talk about synthetic. It's not just your castor oil motor oil, you know. Synthetic division. What's the downfall with synthetic division? What's the one problem that it has? Anybody remember? The issue is you can only use it if you're dividing by a linear term.
Can you explain what a linear term is?
What's the subword of linear? What's the subword of linear? Line. So you're dividing by a line. So it's like y equals x plus 4. Or 3x minus 2. Okay? You're dividing by a polynomial that's got a degree of 1. Okay? Okay? So, if we're dividing by a squared term or a cubic term or something like that, then what do we have to use? Then we got to use long division. And long division works, it's just that. It's long. Okay? So we're going to divide P of x by Q of x, right? Now, that's going to give us a new function, right? And that function is going to be a linear function because they differ by 1. Okay? Now, I can tell you with great certainty that there will be a remainder in that function.
What do you do with the remainder of the whole?
No. How do I know that there is a remainder, that you will get a remainder in that function? Glad I could answer that question. How do I know that you are going to, when you divide P of x by Q of x, you're going to get a remainder? It has nothing to do with the degrees.
The number.
How do I know? How do I know? If there was only a step that we could have done. The what? Which step is that? Step 0, right? Step 0 says we're going to factor it. We're going to simplify it. Right? If I divide and I get a remainder of 0, that means that there's a common factor. And I didn't do step 0. Which is why we do step 0 before we do anything else. Okay? So when I divide, if I've made it this far to step 6, there will be a remainder because I've already factored out my common factors. If you get a remainder, you did something right. If you don't get a remainder, you did something wrong. Okay? You want a remainder because step B here, or sub-step B, says you are going to drop the remainder. because we're dealing with asymptotes. And asymptotes deal with what the function is doing at the extremes, at positive infinity and at negative infinity. And so at those extremes, that remainder is going to be putting one extra grain of sand. I couldn't think of grain there for a minute. It's putting one extra grain of sand onto the beach. Okay? Yes, I've added to the beach, but it's not like I expanded the beach very much. Okay, you know what I mean? At the extremes. Closer and closer and closer to the middle, yeah, it means a lot more. Okay? But at the extremes, it doesn't mean anything.
So then how would you do the...
Just tap the brakes, child. We haven't even gotten to the end of these steps yet. Ay, caramba! Okay? So, and then the last part is your slant asymptote, which we will call SA, okay? VA for vertical asymptote, HA for horizontal asymptote, SA for slant asymptote, is going to equal, or is going to be y equals the linear function that's left over. Okay? Now, go for it, Hunter.
When you go up to the top, did you say if you get a remainder, it's correct, you don't get a remainder, it's wrong?
Yes.
What do you mean?
Well, you do this after you do step 1 through 5?
Yes.
I mean 0 through 5?
Yes.
You do it numerical order.
Why would you want a remainder?
Because then there's no common factor. If you don't get it, if you get a remainder of 0, that means that there was a common factor in your division that you missed
At step 0.
at step
And
0.
You do the whole problem.
And then you got to redo the whole problem. Okay? All right? So, let's do one. Okay? So, what's my very first step? Simplify. Can x squared minus 3 be factored? No. Can x minus 2 be factored? No. So if done with step 0, there's no simplification there. With me? Okay. So then what is the domain of this function?
All the numbers in x cannot equal
Which tells me what?
vertical asymptote is x equals
Okay. Degree of the top. Degree of the bottom.
1.
So this is a top is greater than the bottom case, correct? Which tells me that there is none horizontal asymptote. Right? But why is it a slant?
Because the top is 1 degree higher than the bottom.
Because they differ by 1. So I'm going to put a little note here that they differ by 1. Which tells me I'm going to have to do step 6. Okay?
So step 6, you only do step 6 if you differ by 1.
Yes. Okay? So f of 0 is going to be 0 squared minus 3 all over 0 minus 2. So that tells me that I have a y-intercept at 0, comma 3/2. Right? x squared minus 3 equals 0. So x squared equals 3. So x equals plus or minus the square root of 3. Yes? So that tells me that I have two x-intercepts, one at the square root of 3 comma 0, and one at negative square root of 3 comma 0. Right? Well, what is the square root of 3 without a calculator?
No clue.
1 point something, right? Because the two perfect squares around it are 4 and 1, right? So it's got to be between 1 and 2. So the square roots. Now, is 3 closer to 4 or is 3 closer to 1? 4. So the square root of 3 is going to be closer to 2 than it is to 1, right? So let's go 1.7.
Yeah, how can you do that in your head?
Yeah.
You do that technically what that.
Again, 3 is closer to 4, right?
Yep.
2 is right in the middle.
Yep.
So 2 would technically be like 1.5, even though it's 1.414. Okay? So that means that 3 would have to be somewhere in between there. So it's really kind of like in that 1.75 range.
Ish. 1.75-ish.
It's actually 1.718,
For 9.
I think. Check me out on that. Square root of 3. See, Hunter, I grew up in a time when we didn't have calculators. You know what I mean? So you had to know what the square root of 2 was and the square root of 3 was. You just had to.
I can't remember exact numbers.
I understand that. What did you get, Matt? I know it. 1.73? Yeah, see? Like I said, 1.73.
But how would you do that in your head though?
I just did it in my head 3 times!
You guys should just
Back
stop
out,
asking
where are you
dumb
getting
questions
two from?
now.
Where are you getting 2 from?
What do you mean?
You said it.
Here, sorry for those of you, we're pausing this. So after our number sense break, we're back, okay? Do I have a hole?
No.
Why not?
Because you didn't cancel anything else.
Nothing canceled out, so there is none whole. Okay? With me? Now, here's where we break down step 6. Okay? So it differed by 1, correct? So the first thing that I need to do is I need to divide x squared minus 3 by x minus 2.
Would you put the x squared minus 3 on the inside?
If I'm going long division, yes.
But if you're doing synthetic, it would be nothing.
If I do synthetic, then I'm going to do, first I'm going to say x minus 2 equals 0, so x equals 2. Right? So then the 2 goes on the outside. Then the coefficients of 1, 0, negative 3 go on the inside. Placeholder, Hunter. Okay, with me? Okay, then I do it. Drop the 1, multiply, add, multiply, add.
What do you think would be the easiest way?
Synthetic. But it doesn't always work out. Okay, so this says that this is x plus 2 plus 1 over x minus 2, right? If this were a chapter 5 problem, that's where we'd be at.
But here you're dropping the.
But here, we're dropping the remainder, so my slant asymptote is y equals x plus 2. Joseph, when you come in halfway through class, you're going to miss half of the class.
Half of the class. I
Yes.
know.
Okay?
This is just
So, now I'm going to put that slant asymptote on my graph. Y equals x plus 2 has a y-intercept of positive 2. It has a slope of positive 1. So that's up 1 and right 1, down 1 and left 1. Again, it's got to go on my graph. Because it's an asymptote, it goes on my graph as a dashed line.
Wait, x plus 2, why do you do it x plus 2 to 0 then?
No, y equals x plus 2.
Why did you put a negative 2?
I didn't put it on negative 2.
negative 2x.
I go on to the y-intercept, Hunter, of positive 2. Graphing lines. Okay, with me?
We might have to go over that again then.
Okay, so this makes this part of my graph look like this. Now I got to go on to this side, and I got to find, remember it was x squared minus 3 over x minus 2, and I got to find 3 points over on this side. So let's go with 3, 4, and 3, 4, 5, 6. If I put 3 into my function, I get 6 over 1. If I put 4 into my function, I get 13 over 2. If I put 6 into my function, I get 33 over 4. 6 over 1 is 6. 1, 2, 3, 4, 5, and 6. 13 over 2 is 6 and a half. 33 over 4 is 8.25. So that tells me that this side of my graph goes like that. Now, what about end and asymptotal behavior, right? As x goes to positive infinity, where does my function go?
No, I have a question.
I know, let me finish mine. As x goes to positive infinity, where does my function go? Positive infinity, because it's shooting off way up here. Okay? As x goes to negative infinity, where does my function go? Negative infinity. As x approaches 2 from the left, negative infinity. As x approaches 2 from the right, positive infinity. Okay? Matt first.
What is it? Are you gonna be up one over one for the? Okay.
How did you figure that out? Just one up over.
Because you got
This
one
is my
over
slope.
remainder.
This is my slope.
So your remainder is
Nothing. Remainder gets dropped.
So it gets, so you, that x, whatever you get, more than the slope right?
so if it was 3x plus 2, your slope would be 3.
If it what?
If it was 3x plus 2,
Then it would be up 3 and right 1. Up 3 and right 1.
but now you're gonna be over 1.
No, it's going to be what if it was 2/3? Then it would be up 2 and over 3.
Okay.
So you're just putting, okay,
Okay.
Rise over run.
Go for it. So I do while you do.
I got a question.
I'm listening.
When you simplify it, what? Can you do plus 6
Nope.
minus 1?
Nope.
Oh, I didn't simplify
Why
that.
can't you do
My
plus-
bad.
Because plus 6 times minus 1 is negative 6, not positive 5. I know, every once in a while I have them.
What would your horizontal axis be with the new function?
Oops, wrong way.
I said, would you?
Hold on. We're still not simplifying anything else, really.
Yeah, we did.
We didn't simplify anything out.
We don't only simplify the whole.
That was wrong.
What? You didn't use a new function.
Because there isn't a new function.
What?
Oh,
Oh, so you still want to use the x minus 5 minus
Sure.
Nothing cancels out.
So it stays the same. And even if I would use this one, Matt, this tells me that I've got 2 x's on top, so my degree is still 2. Okay?
So there would be a slant.
I am still on step number 3.
I'm still on step number 4.
These people that's recording that are not going.
Hey, I haven't woken him up lately. Maybe I should wake him up again.
I'm gonna watch this recording.
Oh, whoa.
Tap the brakes, Lindsay.
Whoa.
Tap the brakes.
Whoa. Now we can continue.
What was the warning about?
I didn't put my vertical asymptote on there.
You don't need that, Linz.
Good so far.
Yeah, good so far.
What is it, -5, -1?
Remember, you would have 2 x's instead of 2.
Hold on, I'm waiting to see if they come through. Once not, I must have went to the bathroom. Must have been freshmen walking through that back hallway.
Typical freshman.
I know, I saw.
Should yell that. I teach classes.
He doesn't want to start a bad example from that.
With me?
Yep.
So far?
Yep.
Okay. Holes?
None.
There are no holes.
But I do have a slant asymptote, right? Okay. So,
This one you would have 2 long division.
x minus 2 equals 0, so x equals 2. My 3 coefficients are 1, -6, and 5. 1, 2, -4, -8, -3. What do I do with the remainder?
Cancel it out.
Drop it. So my slant asymptote is y equals x minus 4.
So, the only time you can use this, synthetic division is if the equation such out with x squared, right?
That you couldn't if you're dividing by that x squared, yes.
Or if the numerator is x squared.
I don't care.
So the bottom,
You can only use a linear factor on the bottom.
the bottom has to just be x in order to use simple.
Correct. Whoa, whoa, whoa. Whoa,
Come on, Lynn.
whoa.
What are you rolling, Linz?
Well, it double tapped. Somebody must have been walking in the hallway and bumped the wall, and it popped my pen right off, and it made 2 lines, and
So then,
Rumble.
what would the sand asymptote be then?
y equals x minus 4.
What?
Y
Y equals x minus 4. Okay? So, I have enough in here.
to graph it.
So then,
Not this side.
what? Then what the last side is? Never mind. Oh, shut up.
Okay? I just need to figure out, actually, I really have enough over here Okay, but let's throw an extra one just so we get a second point in here. Let's go with 3. 3 squared is 9 minus 18 is negative 9 plus 5 is negative 4 over 1. 1, 2, 3, and 4. Now I've got enough. So, 2 reminders. Reminder number 1. Blue packet is due next week, Tuesday. Not tomorrow, next week, Tuesday. Reminder number 2. Your test on this stuff is next week, Tuesday. Okay? 2 positive notes to finish class on today. Okay? Good news number 1. You now have enough information to do all of the blue packet. Okay? Good news number 2. Class is